Okay. Good afternoon, everyone. Thank you for joining me today at Velox.com. I'm Shiyan Xu, a founding team member at Onehouse, where I focus on open source development. I've also had the privilege of serving as a PMC member of Apache Hudi project for the past 4 years. Today, I'm excited to share with you some latest development on integrating Hudi with Gluten and Velox, and how this integration is transforming data processing capabilities. Before diving into integration details, please let me quickly introduce Apache Hudi for those who might be new to it. Hudi is a transactional data lakehouse platform. At its core, Hudi defines an open table format and provides a transactional database layer that delivers powerful indexing capabilities, handles concurrent transactions, and enable change data capture. What makes Hudi particularly valuable in today's data ecosystem is how it integrates, how it bridges the gap between traditional data lakes and data warehouses. It offers flexibility of data lakes and also the ASIC guarantee of the data warehouses. Let's start with the progress of what we've made on Hudi and sealed copy on write tables. For those unfamiliar, copy on write or COW is one of the Hudi's table types, where each update creates new file versions, making reads super efficient, but with potential high write amplifications. Gluten support for Hudi COW table was successfully added last year. When querying Hudi COW tables, Hudi identifies the relevant columnar-based files through various indexing mechanisms and creates Hadoop-FS relation in Spark. This relation is then processed by Gluten using Hudi's scan transformer. By using Velox as the backend for execution instead of native Spark, we've observed an overall 33% time reduction in TP-CDS benchmarking. This translates to real cost savings and enhanced user experience in production environment. Now let's move on to the more complex case of Hudi merge on read table. MOR tables have unique challenges due to their hybrid storage structure. Unlike COW tables, MOR table buffer the record updates in role-based log files while maintaining base files in columnar format, similar to COW tables. In Hudi's storage layout, a base file together with its associated log files forms what we call a file slice. When query engine integrates with Hudi, they invoke Hudi APIs to merge those log files and retrieve the latest records. This means a file slice becomes the smallest unit of file scan. For Gluten integration, this architecture requires providing a custom file format that contains both columnar-based file information and associated log file information. When it comes to Velox execution, we need a specialized Velox Hudi data source connector that can process these file slices. More specifically, a connector split reader in Velox should be able to use Hudi APIs to read file slices effectively. This highlighted broader need for a cross ecosystem. For various engines to integrate smoothly with Hudi, we need a common standard API for reading file slices. So this brings me to one of our most exciting development, the Hudi-rs project. Hudi-rs is a native Rust implementation of Hudi, designed to expand ecosystem integrations and standardize APIs across different frameworks. At its foundation, Hudi-rs has a Hudi core component that encapsulate the core models and the logic required to interact with Hudi tables. Building on top of this Rust core, we've developed Python API bindings to tap into the vast Python ecosystem, enabling integrations with frameworks like Ray Data and Daft. For Velox integration, we've recently added C++ APIs by leveraging the Rust C++ binding framework like CXX. With this multiple language approach, we're able to seamlessly integrate Hudi with diverse data processing engines while maintaining a consistent core implementation. The cornerstone of our integration strategy is the File Group Reader API, which provides a standardized interface for reading file slices. In Hudi, a file group is a logical grouping built on top of file slices, capturing records, versioning, and offering numerous advantages in indexing and managing file lifecycles. So in Hudi Rust core, the file group reader is responsible for merging log files with base files and returning Apache Arrow's record batch. So luckily, Arrow provides a stable C interfaces, allowing us to pass a record batch from Rust to C++ by exporting raw pointers. C++ application using Arrow can import the record batch through the same C interface. This approach is also quite efficient due to the zero-copy data sharing within the process. This is supported through the C interface. So looking at the bigger picture, Hudi project is being actively developed on multiple fronts. The main Java implementation recently reached a significant milestone with 1.0 release, introducing powerful new features that enhance Hudi's capability as a data lake house platform. Meanwhile, the Hudi-rs project created just last year with the goal of expanding ecosystem integration and standardizing APIs. Hudi-rs has evolved quickly with 3 releases in the past few months. We will also have a C++ API in the upcoming 0.4 release. As we continue this journey, community involvement becomes increasingly important. I'd like to invite you all to engage with the Hudi community. We are available on various platforms like GitHub, Slack, LinkedIn, and YouTube. For Chinese users, feel free to follow our WeChat account to stay up to date with the latest development. Thank you.